Good morning, everyone. We will wait a few more minutes to see if any other student can join. I posted this worksheet in the usual Google Drive. You can download from there. We have 10 questions for the review today. If we go over it and we still have time, like before 11, then I can go over some question from the exam in the winter term. I think most of it we cover in the tutorial though. Maybe the tricky one is a multiple choice. So I will go over that if we have time. Where do you post this question? Let me check. I'm pretty sure I post in the Google Drive. Wait, I'm not sure if that link works. Let me see again. Can you try that? There is a folder for final exam review. I also share the file for the review that I made for the previous semester and also the link to it. We will start in 2 minutes. Good morning. Please make sure you have the question to follow. I posted in the Google Drive. There is a folder for final exam review. Okay, we will start now. I think I can give you 2 minutes to attempt question 1. It's pretty short. I will recall the binomial theorem for you. All the formulas that we are dealing with today, you will need to remember them by yourself in the exam. Anyone got the answer for this? We want the power of x to be 4. And observe that each term, when you expand this exponent, it will have this form. So it will always be in the form of 6 choose something, 2x to the power of something, and 3 to the power of 6 minus that number. So every term in the expansion will have this form. And we want x to the power of 4. And x to the power of 4 happen when k equal to 4. So if k equal to 4, we will have 6 choose 4, 2x to the power of 4, and 3 to the power of 2. So the coefficient is everything that is not x. So if you exclude the x to the power of 4, then your coefficient will be 6 choose 4 multiply with 2 choose 4 and 3 choose 2. So this is the final answer. Any question about this one? Okay, if not, then I will let you attempt question 2, maybe 2 minutes again. It's very straightforward question. Anyone have the answer for this question? Is quite the opposite. Two events cannot be mutually exclusive and independent. If one holds, the other is false by definition. That's correct. So if we recall, mutually exclusive mean that two events does not have any common elements. So like mutually exclusive mean that A happens, then B cannot happen. And if B happens, then A cannot happen. However, for independent, it means that if we know some information about A, it does not change any information about B. It does not give us any further information about B, which means that it does not increase or decrease the chance that B happen. And similarly, if A and B are independent, then A and B complement are also independent. Because if some information about A does not increase or decrease the chance that B happen, then it cannot increase or decrease the chance that B complement happen either, because B complement depends on B. And similarly, A complement and B complement, they are also independent by that logic. So if we have two events are mutually exclusive, and we know that A happened, then it tells us that B cannot happen, right? So it decreases the chance that B can happen, which means they cannot be independent. If the complement gave information, it would basically be saying that if the event didn't happen, it would give information, which is the same thing as saying if it happened, give info. Yes, that's correct. So for the mutually exclusive and independent question, sometimes you should think about the definition more than just dealing with formula. In terms of formula, for mutually exclusive, we have probability of A intersect B will be 0. And for independent event, we will have probability of A intersect B is a product of probability. Or if we think about the definition that knowing some information about A does not help us gaining any information about B, then probability that B happened without knowing anything about A is equal to the probability that B happened when we know A happened. And it is the same as probability of B when we know that A complement happened. So it is just the same with when we don't know any information about A. And we have that if two events are independent, then they are not mutually exclusive. And if they are mutually exclusive, then they cannot be independent. So these two, you can say it, but it is wrong to say two things. It's wrong to say that not independent means that they are mutually exclusive. This is not correct. You can find a counter example for it. And similarly, if you say not mutually exclusive, mean that independent, this is also wrong. Any question about this one? Okay, if not, then I will let you work on question 3, maybe 5 minutes. It's just dealing with the definition of a distribution. Okay, so for the first one, we throw a die until an outcome of 4 or greater appears for the first time. This actually matched the description for negative binomial. Negative binomial distribution is for number of trials until the rth success. And it just happened here that r equal to 1 because we want to do the experiment until we get the first success. So yes, it is negative binomial and r equal to 1. And probability denotes the probability of success. We denote the event success as when we had outcome of 4 or greater. So when you roll a die, you can have 1, 2, 3, up to 6. And the outcome of 4 or greater is 4, 5, and 6. So probability that we get 4 or greater is 1/2. So P is 1/2 is correct. So this part is true. The second one, we are dealing with the same situation. A geometric distribution is negative binomial with r equal 1, but the P is wrong. Yes, that is correct. So the students say that a geometric distribution with parameter P is equal to the negative binomial with r equal to 1 and the P equal to the value P that we got for geometric distribution. They refer to the same value. And here we are in the same situation, but they are saying that P equal to 1/3, so that is wrong. P should be 1/2, but the distribution is correct. We can say this is geometric distribution with parameter 1/2. Then this would be correct. Next one, a box contains N1 red and N2 black balls. If we select one ball and note its color, and let X denote number of red balls that we selected, then X follow a hypergeometric distribution. What do you think? Yes, it is true. And this is the special case. We will see why in 2 more questions. But yes, it fits the description for hypergeometric distribution. Hypergeometric distribution is when you have N1 objects from some group, N2 objects from another group, and then you draw R objects from both groups. Then X denote the number of objects from group 1. Then we say that X follow a hypergeometric distribution. And here we have 2 groups, red and black. And we sample one ball from there. And then we note the number of balls from the first group. So that random variable follows a hypergeometric distribution. But one key thing that separates hypergeometric distribution from other distribution that we learn is that for hypergeometric distribution, if you sample more than one object, it will be without replacement. So like if you sample, let's say 2 balls from N1 plus N2, then you take the first ball and you don't put it back and you continue to take the second ball. Then in that case, the number of red balls will follow a hypergeometric distribution, which means that when you take the second ball, the probability that you got the second ball depends on the result that you got from the first sample. Whereas for Bernoulli or binomial, the trials are independent and the probability of success stay the same. But for hypergeometric, because you sample without replacement, so the trial are dependent on each other and the probability of success does not stay the same. Now we are dealing with the same problem. We also take one ball and let X denote number of red balls. Let's see, Bernoulli is only when you have only two outcomes. It has a lot more than two outcomes. Why do you think so? Why do you think it has more than two outcomes? If we just select a ball and note its color, then what could be the possible range of X? Number of red balls selected, right? But then we only select one time. Does that make sense? Yeah, maybe the question is a bit fake, but we just select one time and note its color. Same with this question, we only select one time and note its color. If we select more than once, then we need to know that it is with or without replacement. But since we only select one, so it doesn't really matter here. So if you select a ball, you can only get red or black, right? And X is the number of red balls selected. If you get red, then the number of red balls selected is 1. If you get black, then the number of red balls selected is 0. So X only takes on two values, 1 and 0. So X is following a Bernoulli distribution. Bernoulli distribution is used for a random variable when it denotes the outcome of an experiment that can only have two possible outcomes. And here we only have two possible outcomes, 1 and 0. Okay, here we have N1 red and 2 black. We also select a ball randomly, note its color, and return it back to the urn. And we repeat this experiment n times. Let's see. If X is a random variable denoting the number of red balls selected, then X has binomial distribution. The students say that yes, a binomial distribution is a series of Bernoulli trials, which is what we are doing. Yes, that is correct. So this is true because we note the color and return it back to the urn. So what does that mean? That means that the probability of a red ball being selected stay the same throughout every trial. So each trial, the results are independent of each other. So that is Bernoulli trial. Therefore, when we're denoting the outcome for a sequence of Bernoulli trials, then this random variable follow a binomial distribution. But if we change, if we just exclude this condition, if we don't return it back to the urn, then what distribution is X? If we don't return whatever ball we got back to the urn, and X still denotes the number of red balls selected, then X follows a hypergeometric distribution. Because it is the case when we have N1 red, N2 black, and then we draw N balls in total. And we're interested in out of those N balls, how many are red. So that totally fit the description for hypergeometric. When we don't put it back. But if we put it back, it is binomial. Any question about this one? This kind of question would be really easy if you understand the concept, but if you don't, then it's pretty confusing. I will let you work on this one, maybe 5 minutes. Think about how do you pick k element out of the set of n elements like this. So you will have a set of 1, 2, 3, 4, 5 up to n. How many ways are there? You can choose k elements out of this set. So you can show that the two sides are equal to each other. Okay, so we will show that the two sides are equal. By counting the number of ways to choose k elements out of the set 1, 2, 3 up to n. I was trying to make it work with n minus 1 choose k plus n minus 1 choose k minus 1, but couldn't. The thing is, for the question that asks you to show with combinatorial argument, normally you wouldn't need to use any other identity because we don't want to manipulate it algebraically. So don't try to expand a number into something else like you do it algebraically, but rather try to just count something out of that. Okay, so the first way we can do it is just n choose k, right? Because n choose k, it just fits the description. N choose k is the number of ways to choose k element out of n elements. In here, we have n elements and we want to choose k elements out of it. So the first answer is n choose k. The second answer, we will have to make the second answer equal to the right-hand side. So how do we do that? If we look closely, if we look at what does this summation contain? It contains like k minus 1, choose k minus 1, plus k choose k minus 1, up until n minus 1 choose k minus 1, right? When I see this, I will ask myself, okay, the problem I'm dealing with is choosing k elements out of this set. Why? Why in here I only choose k minus 1? Where is the other one item? Where did it go? Why don't I choose it here? The answer can only be the k item. It is fixed and we partition based on that element. So if we look at the set 1, 2, 3, up to k minus 1, k plus 1, and then up to n, like this. The first term is telling us that out of k minus 1 element, I choose k minus 1 element. So we can think of it as out of those k minus 1 elements, I choose k minus 1 element. So what can my k element be? It can be any of them on the right-hand side, right? And similarly, k choose k minus 1 mean that we will have to choose k minus 1 item from this set. And then we realize a pattern that if we fix based on the largest element, if we say that the largest element in the k elements that we have to choose, because we have to choose k elements, right? So out of those k elements, if the largest element is k, then the other k minus 1 elements have to come from this set, right? It cannot be any in this set, because if it is any in this set, k wouldn't be the largest element chosen. So if the largest element chosen is k, then the remaining k minus 1 element has to be chosen from this set. That's why we have k minus 1 choose k minus 1. And if the largest element is k plus 1, then how can I choose the remaining k minus 1 elements? I can choose any number in this set because they are all smaller than k minus 1. So it is k, choose k minus 1. And similarly, if the largest element is n, then I can choose the remaining k minus 1 element from this set because they are all smaller than n. Then I would have n minus 1, choose k minus 1 way. And since they form a partition, why is that? Because the largest element cannot be smaller than k. If the largest element is k minus 1, then the remaining k minus 1 element has to be from this set. But it does not contain enough for us to choose from. So the largest element has to start at k and end at n. And if the largest element is k, then the largest element cannot be k minus 1. So each k's here are mutually exclusive. And they form a sample space, which means they form a partition. So the answer will be just the summation of them by the sum rule. Does that make sense or any question regarding this? Please make sure that you follow what I was saying because this one, it appeared in the past test before. I kind of understand, but will not be able to reproduce this in an exam. The thing is, we will only ask you combinatorial argument question that we gave you before, like is a question that you saw before. So that's a good thing about this course. You don't really have to create something new. It's all the things that you saw before, like in tutorial or in this review session, or like I believe Masul, he put some kind of file regarding practice question about this. Is your argument sufficient or it'll require more words? No, my argument is sufficient. The proof should just be this short or a bit longer if you write in full sentence, but it shouldn't be too long. What do you mean by largest element? So when we choose k element out of this set, one element has to be the largest one, right? Because when we choose is not with repetition, like without repetition. For example, like let's say we choose the set 1, 2, 3 up to k to get k element out of this set. Then in this set, the largest element is k. But if we choose something like 1, 2, 3 up to k minus 1, and then we don't choose k's, we just choose k plus 1, then in this set, the largest element is k plus 1. Or if we skip k minus 1, we choose 1, 2, 3 up to k, but we don't include k minus 1, but we include k plus 1, then the largest element is still k plus 1. So the largest element is just the biggest number from the set of k elements that we chose. Any other question? I know that this is confusing. Like normally, you would need a bit more time to get comfortable with this kind of question. But the good thing is you got access to the solution for most of them. And I believe that your professor, he will not pick something too difficult. He picked something pretty reasonable like this one. If there is no question, I will let you work on question 5. Let me know if you are still confusing about the previous one. Okay, so we have 47 machines here. Out of that, 8 are defective, which means 39 of it is non-defective. I hope I calculated this right. Since there is no replacement, we have a fixed symbol. This would be hypergeometric. Yes, that's correct. So an engineer selects 4 machines at random. Let's see. And X denote the number of defective machines. And when they don't mention anything like this, then normally when you select something, you select it without replacement. We know that X follow a hypergeometric distribution. And if you select 4, machines, then the number of defective machines, it can be 0, 1, up to 4. X equal to 0 means that we have 0 defective items. So everything is non-defective. We just select 4 machines out of the 39 non-defective one. And since we're interested in the probability, because we have to create a probability mass function. So out of 47 machines, we will choose 4. So the denominator represent the number of ways you can choose 4 machines without any restriction. And the numerator represent the number of ways you can choose 4 machines such that all of them are non-defective. X equal to 1, we want 1 defective. So out of the defective, we choose 1. And out of the non-defective machines, we choose 3. X equal 2 means that we want 2 defective items. X equal 3, we want 3 defective. X equal 4 means that we want all defective items. Any question about this table? I choose one item from the defective ones, and I choose 3 items from the non-defective. So in total, I selected 4 items in total, but only one of them is defective. That's what it means. And we want probability that at least 2 machines selected are defective, which means number of defective machines is at least 2. And we look into the table. What is at least 2? It is 2, 3, and 4. So if you take all the value here and you add them together, you will get the final answer. Any question about this one? Why is there a cube? Oh, it's not a cube. It's a page number. Just ignore it. Maybe I should write it somewhere else. Okay, if no question, I will let you work on question 6. No, I didn't realize it looks like a cube, but yes, it did. Okay, so here we have the probability that someone tests positive for disease is 6%. So that is a probability of success. And like for each person, the probability that they test positive is independent of each other. Okay, I see a student answer here. First one, X denote negative binomial with R equal 1 and P equal to 0.06. Yes, that's correct. So the student defined X as the number of people. Examine until the R people are positive. For the first one, we let X denote the number of people examined until we get the first positive. That's why R equal to 1, because we want the first success until the first success. And success is when we see someone who tests positive. And we want to calculate probability that X equal to 8. So we want to calculate the probability that we have to examine 8 people until we see that someone tests positive. Like the 8th person is the one who first got positive. So what does that mean? That means that the first 7 people, they have to be non-positive, right? Like negative. If we have 8 people, and this one is our first positive, then everything before that has to be negative. So we apply negative to 7 people and positive to the 8th person. Then this would be the answer. For part 2, X follow a negative binomial with R equal to 3 and P is 0.06. Because we want that, we stop until the third one who tests positive appear. And we want probability that X equal to 12, which means that the 12th person is the one who tests positive as the third person. So if we have 12 people in total, okay, let's say here we have 12 people. And we want that the 12th one is the third positive. What does it tell us? It tells us that in the first 11 people, there has to be 2 people tested positive already. If there's no 2 people tested positive here, then this one cannot be the third positive. So in order for this to be the third positive, there has to be exactly 2 people in the first 11 tested positive. If exactly 2 tested positive, and we have 11 people in total, which means we have 9 negative. But we don't know the order. We don't know where, like who is the 2 person that tested positive. Therefore, in the first 11 people, we have choose 2 to assign positive. And then we apply probability of being positive to them, and then apply probability of being negative to the remaining 9 people. And then the last person here is positive, so I apply the positive probability to them. Does that make sense until now? Let me know if there's anything confusing. The last one, we want the probability that 20 persons are needed until 5 people have tested positive. So this one, X would follow negative binomial until we have 5 people tested positive. So R equal to 5. And probability of testing positive for each person stay the same. The students say that we use complement law. 1 minus probability of X less than or equal to 19. Is that fully correct? The question is asking for probability that more than 20 persons are needed. Yeah, that looks correct now. So the probability we are interested in is probability X greater than 20, strictly greater than 20, then E is the same as 1 minus probability that X is at most 20 by complement's law. Okay, so if we think about it, what happened when X equal to 20? X equal to 20 means that we have to test 20% until this one is the 5th positive, which means the first 19 need to have 4 positive, and then 19 minus 4 negative. And this logic applies for any number. So it can be applied for 19. If we have to examine 19 people until the 5th positive, then here in the first 18, we need 4 positive and 18 minus 4 negative. And we realize that in order to get 5 positive, at least we have to examine 5 people. If we examine less than 5 people, we cannot have 5 people tested positive. So I will use I to denote the number of people that we examine. I starting from 5 up to 20. Oops. So I will subtract probability X equal to 5, probability X equal to 6, equal to 7, up to equal to 20. And here I have it equal to probability of X equal to I, means that we have to examine I people until we got the 5th positive, which means in the first I minus 1 people, 4 is positive. And I minus 1 minus 4 is negative. In here, there are I minus 1 people and 4 positive. So I minus 1 minus 4 would give us the number of negative people. So out of I minus 1 people, we choose 4 to assign positive. So we apply positive to 4 people. And we apply negative to I minus 1 minus 4, which is I minus 5 people. And then the last one here has to be positive. So we have to multiply with 0.06. So it just makes the exponent become 5. So if you calculate this expression, you will get the final answer. Any question about what I just did? If not, I will let you work on question 7. We are almost there, I think. 3 more questions. If we still have time, we will go over multiple choice for the final exam, like past final exam. Okay, so here we have that the expected number of failures in a day has a Poisson distribution with mean is 1.25. And we know that the mean of a Poisson distribution is just equal to lambda. So if you have x is the number of failures in a day, then x follow a Poisson distribution with lambda equal to 1.25. And we're interested in the probability of 3 replacement required over the next 4 days. Okay, so for part 1, we let x denote the number of failures in 4 days. Then x would follow a Poisson distribution. So in 1 day, we have mean is 1.25. So in 4 days, we would have mean is equal to 1.25 multiplied with 4. I believe this would be 5. And the probability that 3 replacements are required is the same as probability that there are exactly 3 failures, right? So probability 3 replacements is the same as probability of 3 failures. And we recall the PMF for Poisson distribution. This is the only distribution I think you should remember the PMF. Other distribution, you don't need to remember the PMF. So I have lambda equal to 5 here, and my x is equal to 3. And if I calculate this, I will get 0.1404. Part 2 is a bit trickier. Let me see. I might need new pages here. Okay. So for part 2, I want to calculate expected value of replacement made over the next 4 days. We have to denote a new random variable. Y is the number of replacement. Over 4 days. And we will create a PMF table for Y. So the number of replacement that needed over the 4 day minimum is 0. And then 1, 2, let's see. So they tell us that there are 5 replacements in total. So the maximum number of replacement is 5. And we have to fill in here probability that number of replacement is 0. Probability that number of replacement is 1. So we have that probability that replacement equal to 0 is the same as probability that x is equal to 0. I will just write down here first. We will calculate it later. Probability that replacement equal to 1 is equal to probability that failure is equal to 1. and it holds true until 4. Why is that? Because they say if all 5 spares are used before delivery has arrived, then further replacement cannot be made. So the case where we have to replace 5 would have the same probability that number of failures is at least 5. Because if you have 6 failure or 7 failure, you will still have 5 replacement because it is a maximum. So expected value of y will be summation for the value of y multiplied with the probability correspond to it. So y can be 0, we multiply with this probability. Yes, this part is a bit tricky. Like what you might do is you just put x equal to 5 here. And that is not entirely correct. Now I'm just using the formula for expected value. Let me know if I write too small, but I just want to fit everything in one line. And probability that x is at least 5, we can use complement rule to get 1 minus probability that x is less than 5. Zero multiplied with something is just 0, so I ignore it. And then I have plus 5, and then I have minus 5. So probability of x less than 5 is the same as probability x equal to 0 plus probability x equal to 1 up to 4. Like this. So if we continue, we would have 5 minus 5 probability of x equal to 0. I have minus 5 probability x equal 1 plus 1 probability x equal 1. So it is minus 4 times probability of x equal to 1. And then plus 5, minus 5 for x equal to 2 and plus 2 probability of x equal to 2. So minus 3. And then minus 5 probability x equal to 3 and then plus 3. So we have minus 2. And then lastly, we have minus 1 times probability x equal to 4. And then x is just a Poisson random variable. So we use the formula here to calculate probability x equal to some specific value. So we see that all of them have a common e to the power of negative lambda, which is e to the power of -5. So I will pull it outside. Inside is this coefficient, this one, and then multiply with lambda to the power of x divided by x factorial. Lambda is 5, so I put 5 to the power of 0 divided by 0 factorial. And the final answer would be 4.123. Any question about what I just did? If there is no question, I will let you work on this one. But if you're still confused about the previous question, just let me know. So this is a graph of what is EP on purpose? No, it is a typo. Just ignore this E. I just mean the probability of X is between 1 and 5, given that X is greater than 6. There is no E there. So if I graph this piecewise function, then this is a graph that I got. And I need to fill in from 2 to 5. What does a function look like? So they ask for what are the possible values of the constant k above. We know that a distribution function is non-decreasing, which means the value from 2 to 5 cannot be smaller than the value from 1 to 2. Because if it is, then the function is decreasing. But a distribution function is non-decreasing. And it also means that it cannot exceed this value. Because if it exceeds this value, then the function will also become decreasing. Which means k has to be between these two numbers. So I have 0.35 is smaller than or equal to k and smaller than or equal to 0.85. Yeah, since ft is a CDF, k can be anything from 0.35 to 0.85. Yes, that is correct. And then a student say that this random variable is discrete, and he also listed the values for x, which I think is correct. So the thing with discrete random variable is that its distribution function, given any interval of input, the value of the function is a constant. It is not like a changing function. If it's not something like t squared over 2, if you see something like this, it is not discrete. In order to be discrete, all the number here has to be a constant. And the graph, it would always look like something like this. Like it's like a stair, and then at every level is horizontal. It does not increase like this. So x is a discrete random variable, and the range of x is 1, 2, 5, and 12. We know that because every time that you see a jump, then like the probability at that point is positive. Like at 2 and 5, they might like at least one of them has to be a jump, or like both of them can be as well. So it depends on the value of k. But if k is something in the middle like this, then at both 2 and 5, there is a jump. So the range of x would include both of them. But for example, if it is something like this, then the range of x does not include 2 and only include 5. It only includes the points that have the jump. So they ask us to find those probability given that k is 0.6. So I will have 0.6 here. And then in my graph, I have 0.6. First one, I want probability that x is between 1 and 5 and include 5. So this is just probability x is less than or equal to 5. Subtract x less than or equal to 1. And then this is just f of 5 subtract f of 1. I think what you wrote is f of 5, right? But we do need to subtract. And this is 0.85 because you plug 5 into the function and this interval include 5, so you take the value. And for 1 is 0.35. And the answer is 0.5. Probability x equal to 2. Probability that x equal to something is just how much do you jump at 2. You jump from 0.35 to 0.6. So the gap between them is equal to probability x equal to 2. In terms of notation, we will write it like this. Is probability x is at most 2 minus probability that x is less than 2. So this is f2 subtract f of 2 minus. F of 2 is this value, 0.6. F of 2 minus is this value, which is 0.35. So the answer is 0.25. Let me know if you have any question about what I just did. Next one, I use conditional probability formula. I need x to be at least 2 and x is greater than 1, which just means probability of x is at least 2. Because the intersection of both condition is just x is at least 2. Divided by probability x is greater than 1. I think I might need a new page. And then probability of x is at least 2 is 1 minus probability of x less than 2. Probability of x is greater than 1 is 1 minus probability of x less than or equal to 1. So probability of x is less than 2 is f of 2 minus. And probability that x is at most 1 is f of 1. F of 2 minus, as we say here, is this value, 0.35. So if you subtract, you would have 0.65. And f of 1 is also 0.35. That's strange. Did I make a mistake somewhere? Probability. Maybe no, because it's discrete. And we would have 1 here. So this actually makes sense because they say that if we know a discrete random variable x is greater than 1, then what is the probability that x is at least 2? Then that should be 1 because we know for sure that if x is more than 1, it has to be at least 2. It cannot be anything in between because x is discrete and the range of x is given by this. And let's look at the next one. The next one asks us, given that x is greater than 6, then what is the probability that x is between 1 and 5? One students say that this one is 0. Yes, that is correct. Because if we think about it, if x is already greater than 6, there is no way for x to be between 1 and 5. So the probability of something cannot happen is 0. Last one, we use conditional probability again. This one intersect with x greater than 1. Just give the expression itself. Okay, the denominator we calculated above. So I will just copy it down. And then this value can just be used, this value subtract when x equal to 5. Probability x equal to 5 is the jump when we have 5. So the gap between these values. So it's 0.85 minus 0.6, which is 0.25. And this would be the final answer. Any question about that? Let me know if anything doesn't make sense. I will let you work on question 9, maybe 3 or 4 minutes. Okay, so for the question that asks you find a constant so that something is a probability mass function, you just need to make sure to find a constant c such that the summation of the function over every value of x is equal to 1. Student got 1/2 for part 1. I think it should be correct. Let's see. So I want the summation of the function over all value of x ranging from 1 up to infinity. I want this to be equal to 1 because it is a property of probability mass function. If I expand it out, I will see that there's a geometric series. When x equal to 1, I have 2 over 3. X equal to 2, I have 2 square over 3 square. X equal 3, I have 2 cube over 3 cube. And it has to add up to 1. And for geometric series, like infinite geometric series, we can calculate the sum by taking the first term divided by 1 minus the ratio. The ratio is the ratio between two consecutive terms. So if you take this term divided by this, you will get 2 over 3. So the ratio here is 2 over 3. And you would have 2 over 3 divided by 1 over 3, which is 2. So C equal to 1 over 2. We do the same thing for part 2. We want that x over c summation from x equal 1 up to n equal to 1. For 2, I'm not sure, is 1c times sum of x1 to n, which means c is a summation of x to n. So c is a constant, so we can pull c out, right? And inside we just have x, and x ranging from 1 to n, like this. If you expand the series out, you will have 1 plus 2 plus 3 up to n. And you should realize this arithmetic series. The difference between every term is the same. So is like arithmetic series. And if we use a formula, we would have the summation of these is n times n plus 1 divided by 2. Another way to calculate it, I will write it down here. Let's say we want to calculate a sum of 1, 2 up to n. And we realize that if we have 2s, it would be 1 plus 2 plus n, and then plus itself one more times. And then we can group I write in the whiteboard direction, and I group the term 1, I group to n. 2, I group with n minus 1. And lastly, n group with 1. So we see that the sum of each group will be n plus 1. And how many groups are there? The number of group is equal to the number of elements here, which is n. So you would have n times n plus 1. Therefore, S to be n times n plus 1 divided by 2. And S is a sum from 1 up to n. So that is how you can calculate this if you don't remember the formula for arithmetic series. Okay, so here I would have C equal to this one. I think so. Oh no, actually, it'll be the reverse. Like this. Any question about that? For part 3, it looks very similar to what we did before. So I just write down the expression for f and x ranging from 1 up to infinity. And if I pull c out because c is a constant, then I got this expression. It's very tempting to say that this is e to the power of 100, but it's not quite there. because the series expansion for e to the power of x is a summation like this, but n starting from 0 up to infinity. Here we have starting from 1. We have n starting from 1. So we cannot just say it is equal to e to the power of 100 because that is not true. However, we see that if we add this term, then I will have this series here. So what I can say is it is equal to the summation starting from 0 subtract the value when it is 0. And the summation is e to the power of 100. And the other term is just 1. And I want that the whole thing is equal to 1 to satisfy a probability mass function property. Then I would have C equal to 1 over this. Yeah, that's correct. Okay, so we have the answer here. Does that make sense to everyone? Okay, for the last question, since we are running out of time, so I will just cover it. We know that 50% of the email are spam. So we know that spam is 50%. And then that means some email is non-spam is 0.5 probability. And they say that a certain brand can detect 99% of the spam email. It means that if the email is spam, then the probability that it is detected is 99%. And not detected is 1%. And false positive mean that a non-spam email but got detected as spam is 5%. And a non-spam email is not detected as spam is 0.95. We want to calculate the probability that if an email is detected as spam, so given that it is detected as spam, what is the probability that it is a non-spam, which is S complement. If we use the conditional probability formula, this is what we got. And S complement intersect with D is just this part here. So we multiply two numbers. In the exam, we do expect you to write down like is something like this. Just write down what does each number represent before actually plug it in. And the denominator is probability of detected. And it is detected in two ways. This way and this way. So we just add up probability from two ways. The final answer would be what we are looking for. Any question about this one? This is the last question for our session today. If you have any question, feel free to post on Piazza. If there is no other question, I will stop the session here and good luck on your exam. I believe you will do well.